Commonly used discrete probability distributions. Part 1. Two commonly used discrete probability distributions are the binomial distribution and the Poisson distribution. These are based on the principle of Bernoulli trials or processes. Let us look closely as to how binomial distribution works. Look at this example. Let x denote a random variable, Rv, that indicates the number of times an event occurs in n Bernoulli trials with probability p of occurrence in trial. Then, x is said to follow a binomial distribution with parameters n and p. P is referred to as probability parameter. If p is the probability of occurrence in a trial, the probability of non-occurrence is q equals 1 minus p, which is also a constant. So, when x follows the binomial with parameters n and p, x can take values 0, 1, or up to n. Then, probability x is equal to 0, which is equal to q into q up to q is equal to qn as outcomes are independent. This follows from the multiplication theorem of probability. Similarly, probability of PR is x equal to Pn. And more generally, probability of PR is equal to x, which is equal to or equal to NCR into PR into Qn minus R, where R can vary from 0 to n. Value probabilities can be obtained from statistical tables or using software. Let's look at another example. A supplier company's process is such that it has a 0.3 probability of producing a defective piece. What is the probability that an inspection sample of size n has A. 2 or less defectives, B. 4 or more defectives? And the solution will be like this. Let x denote the random variable indicating the number of defectives in the inspection sample of size 10. Assuming that the process is Bernoulli, x follows a binomial with parameters n equals 10 and p equals 0.1. The probabilities of x taking different values are as follows. Probability that the inspection sample has 2 or less defectives is probability of x less than or equal to 2, which is equal to probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2, from the addition theorem on probability, as the three alternatives are mutually exclusive, equals 0.3828. Probability that the inspection sample has 4 or more defectives is equal to probability of x is greater than or equal to 4. Equals 1 minus probability that the inspection sample has 3 or less defectives, which is equal to probability of x is less than or equal 3. Which is equals 1 minus 0.6496. Which is equals 0.3504. Note that the result justifies the assumption that the process is Bernoulli. In the next video we shall explore Poisson distribution.